Hi, so in this video we're going to find the distance between a point and a line in R3. And to do that we're going to use the cross product. So let's see, what do we mean by the distance between the point and the line? Of course we mean the perpendicular distance, right? If I have a line like that in space, pretend this is an R3 thing, then I have, well, it really doesn't matter if it's an R3 and R2. We usually think about it as an R3, but once we have the line and we have a point outside of the line, right? Sorry, I don't want that to be P0. So I have a point outside of the line. Then I'm going to talk about the distance between the point and the line. Of course, we mean this perpendicular distance, right? That's the line, the distance we're thinking about. So once I have the line and the point, there is only one plane that goes to the line, contains the line and the point. So this is going to be in, really everything in this picture is now in the plane, right? So okay, so then once I have that plane, I'm thinking about this triangle. I can make a triangle by picking any point on the line that's not the P or the base of my red line. So pick a point over here, and this would be any point on the line. Let's call it P0. So I have a triangle if I complete this right here, right? So that's a triangle. And like I said, this is already in R3. This makes a line, a flat a triangle in the plane. So let's call U the vector P minus P0. So it doesn't matter which direction the arrow is, but P minus P0 would be the one with the tip of the arrow at P. And look at this triangle that I have with this angle right here. So this is a right triangle, and the hypotenuse is the magnitude of the vector U. So the sine of that angle is the opposite, which is the D, the distance I'm looking for. Let me make that one red, just to keep things in context. So it's that divided by the magnitude of U, which means that my D is really the magnitude of U times the sine of the angle theta. This is just trick. So how do we get this into the idea of a cross product? Well, if you remember, the cross product gives you a vector, and its magnitude is magnitude of U, magnitude of V, sine of the angle between them. And that's what I have here. Right, I'm sorry, I have the magnitude of U and the sine of the angle theta. So I can kind of complete that by using a V vector. Now, V vector has to be a vector along in which we took the cross product, for which the angle theta is the angle between the U and the V, which means that V has to be a vector in this direction, right? It could be any vector in that direction. So now I'm going to give a little simple argument, but the line, if we have the line expressed anyway, we should have 2 points on the line, or if we have given the equation of a line, which if you remember, the lines in R3 are given like P plus TV. And on purpose I'm using the V, because the V could be arbitrary, and the P could be arbitrary. So I can assume that the point P of the line is the P0 that we were given, and that the V of the equation of the line is the V that I have there. Okay, so basically now we can start over and say, if I have the equation of a line given like that, and we can always have it like that, then we pick the P0 to be the point P here, and we pick the V to be the V given in the line, in the equation of the line, and then we just have to do is complete this by multiplying by the magnitude of V and dividing by the magnitude of V. Why did we do that? Because now the D is really just the magnitude of U cross V divided by the magnitude of V. And that's the formula for the distance between a point P outside of the line and the line given by P0 plus TV. Okay? So let's do that in context. Let me just write here where u is p minus p0, and p is a point outside of the line, and p0 is a point on the line. Okay? So let's copy this guy and use it over here. So I have an example to work on. So find the distance between the point P, 1, 3, 2, and the line 3 plus t, 1 plus 4t, negative 1 plus 5t. Let me paste my formula that we found. This is the distance I'm looking for. So the only thing I need to work on a little bit here is that this I had to identify like P. This is the line. I need to identify like P, well, P0 in this case, plus TV. So who is my P0? Well, we don't have to break it up, but if you, just for making things more clear, you can break this up like the 3, 1, negative 1, plus t times the vector 1, 4, 5. Right? 3, 1, negative 1, plus t times the vector 1, 4, 5. That way, this is my vector P0, this is, or my point P0, this is a vector V. And now using my, what I said over here, what I need is that my u has to be p minus p0. My p is given up here, so my u is the vector 1, 3, 2 minus p0, which is this one, 3, 1, negative 1. So it becomes 1 minus 3 is a negative 2, 3 minus 1 is a positive 2, 2 minus a negative 1 becomes a positive 3. So it's a negative 2, 2, 3. That's my vector u. So I need to find the vector u cross v. So to find the u cross v, I'm going to write the e1, e2, e3, put my u vector, negative 2, 2, 3, write down my v vector, which is this one, 1, 4, 5. And I have to calculate this determinant. So I do here, let me see if we can do it this way. If I do 10 minus 12, let's write that down, 10 minus 12. Let me erase just the highlighter. And now I'm doing, I do the cross product in the middle term backwards instead of changing the sign outside. I'm going to do 3 times 1 minus this times that, right? So that minus that. So I get a 3 minus 10 minus a negative 10, so plus 10. Okay? And now my third one becomes just this minus that. So my third one becomes, I'm going to go back to blue, negative 8 minus 2. If this was a positive 2, this minus here is something different, right? That was part of the arrow. Okay, so my cross product became 10 minus 12 is negative 2. 3 plus 10 is 13, and a negative 10. Okay, I'm almost there. What I need to find now is the magnitude of my vector v. So that's the magnitude of this vector v up here. So it's just a square root of 1 plus 16 plus 25, and that's 42 square root. So there we go. The distance that I was looking for was the magnitude of u cross v over the magnitude of v, which is just, oh, I didn't find the magnitude of this one. Let's do it up here just to put it in context. It's a little bit of 4, 169, and 100. So it's 273. So my distance is just the root of 273 over the root of 42, or in the one root. There you go. Okay? So this is how we use this. And if you need a decimal approximation, we can find it.